Hello students, today we are going to discuss the third numerical of influence line diagram for bending moment. Question is written as the correct values of the bending moment MA in kilonewton meter at the fixed end A in the statically determinate beam shown below with internal hinges at B and D when a uniformly distributed load of 10 kN per meter is placed on all spans. It means that we need to find the moment at A when 10 kN per meter UDL is placed on all spans. The beam is having fixed support at A, roller support at C and E, and having internal hinges at B and D. Now to find the moment at A, we need to plot the influence line diagram for bending moment at A by using the Muller-Breslau principle. According to the Muller-Breslau principle, for plotting the influence line diagram, we need to displace this portion by unit rotation. Now due to internal hinges present at B and D, the deflected shape will be like this. Now for the calculation of moment at A, we need to multiply this UDL intensity with the total area, that is this area and this area. So the total value will be equals to minus 1 by 2, that is half, into base into height. Base is 4 meter and height is 2 meter, plus this area, half, base is 4 meter and height is 2 meter, into total UDL intensity, that is 10 kilonewton per meter. Now this area will cancel out each other, so the total moment at A will be equals to 0 kilonewton meter. That is all about this numerical. Thank you very much, students.